So we are going to talk about page 3 in our college pre-calc 1.2 notes. So the first thing is going to be intercepts, and then we'll move on to symmetry. So an x-intercept. An x-intercept is when a graph intercepts an x-axis. So here we would have two of them. We'd have one at -4 and one at 2. A y-intercept is where it intercepts the y-axis, which would be right here at -3. So how you find those? If you have a graph, you can look at the graph. If you don't have a graph and you just have an equation for an x-intercept, we are going to want to take and plug in 0 for y. The reason we want to plug 0 in for y is because if you're on the x-axis, the height of the graph has not gone up or down. It's sitting right here, right at the baseline here. So the y coordinate of these has to be 0. Like this one is over 2 up 0. This one is -4 up 0. Because an x-intercept has not gone up or down, you'll plug in 0 for y and then solve for x. When we do the y-intercept, we're just going to kind of turn everything around with our x's and our y's. So here, this is the y-intercept, and it's over 0, down 3. So it's 0, -3. A y-intercept will always have a 0 here. So you'll plug in 0 for x, and then solve for y. That's how you get your y-intercept. If it's a function, you could have lots and lots of x-intercepts, but you should really only have one y-intercept, or else it would fail the vertical line test. So we'll do one example here. I have find the intercepts for y equals x cubed minus 4x. So I'll start with x-intercepts, and I have to have my y equals 0. So I have to plug in 0 for y. And I need to solve. This is a factoring problem. I'll factor out the greatest common factor because there's two terms, and then I'll solve. So x is my greatest common factor. If I factor out an x, I'm dividing out an x, so I'd be left with x squared minus 4. I can continue to factor. X squared minus 4 is the difference of two squares, so I can have x and then x plus 2 and x minus 2. So my x-intercepts would be whatever makes each of these factors 0. So I would say 0 for that one, -2 for that one, and 2 for that one. So I'm going to write it how I wrote these. So it'll be 0, 0, -2, 0, and 2, 0. All right, y-intercepts. I'm going to have 0 in for x this time. I just kind of write that as a reminder. So it'd be 0 cubed minus 4 times 0. 0 cubed minus 4 times 0 would be 0. So my y-intercept is 0, and that was 0 for x, and then I would also have 0 for y. All right, now we'll talk about symmetry. With symmetry, we can see symmetry when we have a graph. We're also going to talk about how to algebraically test for symmetry if we don't have a graph. So it's kind of little, but you can see this is x-axis symmetry. And x-axis symmetry happens when you have a line of symmetry on the x-axis, and whatever is up here would be reflected and have the same look down here. So you can see that everything here, if you flip it across, it would lay right on itself. X. This is y-axis symmetry, where your line of symmetry is here. Everything that's here, you can flip it over here. And then origin symmetry is where it's actually rotated around the origin, which is here. Couple things, couple ways to think about it. It's like 180-degree rotational symmetry. So if you take whatever's over here and rotate it around, it's down here. If you take whatever is here and rotate it around, it's down here. So you could think about it as 180 degrees rotational symmetry. Or you can also think about it as it reflects across both axes, so x and y axis. So like you would take this, you would flip it here, and then you'd flip it here. So whatever's in quadrant 1 ends up in quadrant 3, here, here. Whatever's in quadrant 2, flip, flip, ends up down here. So a couple different ways to think about origin symmetry. How do you test? Well, there are 3 of them, so we will talk about how to test for each one of them. So for the first one, how to test for x-axis symmetry. First, you take whatever equation you're given and you switch y out for negative y. The reason that you do that is if a point is on the graph at xy, it should also be on the point x negative y. So it should hold true whether it's y or negative y. Second, you simplify. Third, if your simplified equation is equal to your original equation, then there is symmetry because it's like taking a point. If it's still on the line and you can simplify it back, still on the line, then it does have the symmetry. So if the equation, abbreviated equation, if equation is back to original equation, there is x-axis symmetry. All right, y-axis symmetry. Everything is the same idea. If you have xy, if you reflect it across, the x now becomes negative. So we're going to switch out x for negative x, and then we're going to simplify, and then 3 is the same as that. If the equation is back to the original, then there is y-axis symmetry. Okay, so very similar. Origin, same process. You want to switch x and y out for negative x and negative y. So in your equation, you'll have x and y. Each of them will be taken out and put back in with a negative. Then you'll simplify. Then, same, but origin symmetry.